Okay, so we left off talking about how this nasty exponential function would have been moved compared to the original one. Now, one thing I want to warn you about is if you've done a whole bunch of changes to your function, then you can't count on this being the y-intercept anymore, okay? Because there's been just too many things have happened to it. You can go back to, though, the y-intercept is where what again? X equals 0. So I can stick in x equals 0 right there. But then I'd have 0 minus 4 is negative 4. 1/2 times the negative 4 makes negative 2. And then I'd have negative 2 times 3 to the negative 2 plus 8. Would you agree that that is not going to be equal to 3, very likely? And it's not also not equal to 2. So your y, it actually ends up being some nasty fraction. But bottom line is that your y-intercept is always where x equals 0. But you can't count on that little rule of that number in front is always the y-intercept. If it's had a lot of changes done to it, then you can't count on that anymore. So you can always go back to some facts like the y-intercept is where x equals 0. That you can trust. All right. Next, let's talk about this one. Here they have two graphs. The really dark black one here is the parent one, and it says that in the directions that it's taking y equals 2 to the x, shown in black, and then it's making this red curve. And it's basically trying to say, how did you change the black one to turn it into the red one besides making it red? Well, you have to shift it or you have to stretch it. Okay? Well, if I do this, I think you'll be able to see it a lot better. Watch if I take this, I drew it over the top of it. Okay? And watch if I move it just straight to the right. Doesn't seem like I moved it straight to the right, but I did. And you see how it matches up perfect? These are kind of counterintuitive. They don't look just like a shift to the right. It seems like it's more of a stretch, but it was just a shift. All right, and how could I tell that if I didn't have a neato whiteboard that I can drag something across like that? Look at these two dots and then those two dots. What they're trying to say is that those two dots are in the same place on that line, and they have just simply moved, and you can tell where they went. That one went 3 to the right, and that one went 3 to the right. And they're still the same distance apart from each other and everything. So I can tell that this thing just went 3 to the right. So if the parent looks like this, to do it 3 to the right, I just have to add that part right there, which is up in the exponent right by the x. It was a left-right thing. Okay. This one, here's my two dots. Here's my two dots. The black one is the original, the parent one, and the red one is the new one. Now this is actually problems from your worksheet that I'm going to give you in just a minute. And the worksheets are always black and white. So how in the heck are you going to tell which one's red? Well, the one that's black is supposed to be black is the one that always goes through that spot right there. Okay? And they'll always, of all four of these graphs, or all four of them have that one line that runs right through one. And it looks exactly the same on all four graphs. That's the black one. The other one on the sheet, that one must be the red one. And you can tell if you look real close, the one on your worksheet that's a little more faded is the red one, because red doesn't pick up as well on a photocopy as black does. All right, so you'll be able to tell now which one's which. This one, it looks to me like they've just been moved up 2. Would you agree? So then if the original parent one is y equals 2 to the x, then how do I make it move up 2? Plus 2 at the end, like that. If I wanted to check, could I use my graphing calculator and type in that and see if it shifted up? Yes, I could. All right, so that's all you'd have to do. If you want to put this into your calculator, just remember to do y equals, the y equals screen will be there. And you want to have 2 to the x, you go 2 to the power of, remember that little caret key? To the power of x. It's not a triangle, it's supposed to be a caret. 2 to the power of x. That's how you'd put that in the calculator. Yes, it's called a caret. All right. I will warn you on your worksheet, the very last one on the worksheet is really hard. And a few kids have figured it out just like doing lots of figuring. But there's a lot of them have been flipped. Some of them have been flipped 2 different ways. Some of them have been flipped and stretched. And they can be hard to figure out. But look for your key points. Like here I got these 2 points. And then I drew over this so it's hard to tell where the other ones are. And here I have these 2 points. Can you tell me, has that one just been shifted? Now, it looks to me like it's been stretched somehow, and you just have to start figuring out, well, if it starts, the parent is this, and if I want to stretch it, well, maybe do I put the stretch part here, or do I put the stretch part here, or, what do I do? You have to figure that out. All right, so that's what your homework is like for today, and I will hand them out.